Number 18, 16, 6 points, determine angular acceleration of solid uniform 40-pound disc. So we're rotating about a point right here. Okay, there's a force at an angle on the edge of this disc. Okay, so it's rotating like that. We want to determine the angular acceleration. So hopefully you recognize this. Torque equals I alpha. Okay. So we use the origin here, so the torque of this force about that origin is the force times the perpendicular distance. We will break that force into two components, one going vertical that way, one going horizontal that way. This one's line of action goes through the center, so it does not have an effect on the torque. This one is 12 cosine 25, and that one is at that 8-inch distance. Alright, and we'll use counterclockwise as positive. Okay, so this would do a positive rotation, counterclockwise rotation. So we're going to have 12 cosine 25. That's going to be pounds. So there's our force times our perpendicular distance, 8 inches. And we'll convert that to feet. Foot, 12 inches. Okay, so there's our torque. Okay, we need to calculate I for a disc. Is equal to, again, we will give you these equations. On this particular exam, they were given on a cover sheet, so I'm going to scroll back up and find a disc. So here's a cylinder. A disc is the same thing because the depth doesn't matter. It's just 1/2 mr squared if we're rotating about the center point. So 1/2 mr squared is our equation for I. Okay, mass is 40 pounds, or 32.2 feet per second squared. And again, the radius in feet is 8/12 feet squared. Let's see, how do I want to write that? Alright, so calculating our I here. 0.5 times 40 divided by 32.2 times 8/12 squared. 276. Okay. We know I is going to be units of mass and length squared. We could work through that. Pounds over foot per second squared, slugs, and then the foot squared comes from that. Alright. Zero 276 slug foot squared. There's our I, and our alpha is going to come from that. So alpha is going to be equal to 12 cosine 25 times 8 divided by 12 divided by 0.276. 26.26 or 26.3. Okay. Let's look at units. Let's see. Come on, colors. The inches will cancel out there. Okay. So if we just write out our units here, it's going to be pounds, feet, so pounds and feet divided by slugs, foot squared. Pretty weird unit until we remember that pound is equivalent to slug foot per second squared. Alright, so slug, slug, pound, pound, foot, foot. So it's going to be units of 1 over second squared, which is in rotational motion terms could also be written as radians per second squared. Okay, so 26.3 radians per second squared. If we want to include a direction, we could say counterclockwise to indicate that it's accelerating in that direction.